Hello and welcome to lecture 22. We are discussing the properties of indifference curves, and if you recall, we have listed four of these properties. One was that indifference curves are downward sloping. We said that if they were upward sloping, and that can't arise in our world, it would violate the more is better condition, right? Because if you look at the graph, bundle B has more of good X and good Y compared to bundle A. So, I should clearly prefer bundle B over bundle A, but that is not the case, right. So, indifference curves are always downward sloping in my world. Similarly, higher indifference curves will denote higher levels of utility, right. So, as I move in the northeast direction, if you prefer, right. So, as I move in the northeast direction and I draw of the xy space, I will have levels of utility which are represented by higher numbers. Okay. The third and very important property which we are going to be proving just now is that indifference curves cannot intersect, and the fourth property that we said was indifference curves are not thick, right. So, they are going to be smooth thin curves. Okay. Now, so let us try and prove very quickly the third property, that ICs cannot intersect. Okay. And let us also use this picture here to help us make the argument, right. So, let us start by saying, suppose indifference curves could intersect, right. Suppose indifference curves could intersect. So, suppose let us say I have indifference curve 1 here, IC1, and let us say I have IC2. Suppose indifference curves could intersect, and let me call this point to be B, and let me take two other bundles here, bundle A here and bundle D here, right. So, I have two indifference curves IC1 and IC2 which are intersecting at the point B. I have two bundles A and B which are on indifference curve IC1, and I have two bundles B and D which are on IC2, and I have intentionally taken D to the northeast of A, right. Okay, you will see why in just a moment. Okay. Now, a few immediate things that we can claim. Now, we know that bundles A and B are on the indifference curve IC1, they are on the indifference curve IC1. So, if I give the consumer a choice between these two bundles, the consumer is going to say that I am indifferent between A and B, right. Because I have two bundles which are on the same indifference curve, it must give the consumer the same level of utility. So, if I ask the consumer to rank or order or make a choice between these two bundles, the consumer is going to say that I like them equally, I am going to be indifferent between A and B. Similarly, bundles B and D are on the indifference curve IC2, bundles B and D are on the indifference curve IC2. So, if you now ask the consumer to rank bundles B and D, the consumer is going to say that both of them give me the same level of utility. So, I am indifferent between B and D, right. So, let me call this to be point 1, let me call this to be point 2. So, we took two bundles on IC1, and because they are on IC1, the consumer is indifferent between those two bundles. Again, we took two bundles on IC2, because they are on the same indifference curve, the consumer is indifferent between B and D. So, now notice I can apply transitivity from 1 and 2 using transitivity, and notice, which is why we had listed transitivity as an important structure on our preferences earlier, right. So, from 1 and 2 without transitivity I will not be able to make that statement. So, I need that to make the following statement. From 1 and 2 using transitivity, it follows that the consumer is indifferent between A and D, right. I am indifferent between A and B, I am indifferent between B and D. So, if you give me A and D, I am going to say that I am going to be indifferent between A and D. Well, what is the problem? The problem then is that if I am indifferent between A and D, both A and D must lie on the same indifference curve, which clearly they are not. In fact, the way I have drawn it, bundle D has strictly more amount of good X and more amount of good Y compared to bundle So, but bundle D has more of good X and more of good Y compared to bundle A, which means that by the more is better assumption, by the more is better structure on preferences, it means that consumer strictly prefers D over A. Now, I cannot say that I strictly prefer D to A and also claim that I am indifferent between A and D. So, this contradicts. So, this is a contradiction, right? And the source of the contradiction is that I started with an incorrect statement, right? The reason I arrived at a contradiction is because I started with a claim or started with a statement which was incorrect. I started with a statement saying that indifference curves could intersect, and I have reached a point where I am contradicting between two claims. One, I am saying that I am indifferent between A and D, and on the other hand I am saying that I strictly prefer D over A. So, both cannot exist together. Okay. So, this is sort of the proof for why indifference curves cannot intersect. So, be very careful when you draw indifference curves. When you are practicing drawing indifference curves, make sure that for the same consumer, right. So, you are looking at a single representative consumer. For the same consumer you are trying to draw indifference curves, those indifference curves cannot intersect, okay. So, from now on we will go back to our utility function of the form u of xy. So, let us say I have a utility function of the form u of xy is equals to x times y or square root of xy, whichever is the case, and we are interested, these will be indifference curves which are downward sloping, and we are interested in finding the slope. So, we are interested in finding the slope of the indifference curve at a point. So, interested in finding the slope of the indifference curve. We know that the indifference curves are downward sloping, but we are interested in trying to find out what is the magnitude of the slope, interested in finding the slope of the indifference curve at a point on the IC, right. Now, we will compute the slope, right. Before we compute the slope, and in fact it turns out that in order to compute the slope I will need to define two terms, right. So, the first definition that I am going to put on the board is the notion of marginal utility, right. So, to talk about the slope need to define marginal utility of x, marginal utility of good x, and the marginal utility of good y, right. Let us start with the marginal utility of good x, marginal utility of or from, whichever way you want to write it, right, marginal utility of good x. Now, I am going to represent this as mu for marginal utility, and I will put a subscript small x to denote that it is the quantity of x that I am changing. Recall, good x could be food and small x denotes the quantity of good x. Now, let me first state the definition. The marginal utility of good x, is the change. Recall the definition of marginal revenue. The definition of marginal revenue was a change in total revenue resulting from a unit change in the quantity produced. So, similarly, marginal utility of good x is the change in total utility or utility resulting from a unit change in the quantity of good x keeping the quantity of good y constant. Right. So, when I am computing MUX, I am interested in finding the change in utility resulting from a unit change in the quantity of good x, and recall there are two goods, right. So, now I am working in the two dimensional plane, quantity of good x on the x axis, quantity of good y on the y axis. So, when I am changing the quantity of good x, I want to keep everything else fixed. In particular, I want to keep the quantity of good y fixed, so as to exclusively identify what is the impact on utility due to a unit change in the quantity of x. So, a delta x change in the quantity of good x, let us say, leads to a delta u change in the utility, which implies that a unit change in the quantity of good x is going to lead to a delta u upon delta x change in the quantity of good x. So, if I can change x by a discrete amount delta x, suppose I did that change and my utility changed by delta u, a unit change in the quantity of good x is going to lead to a delta u upon delta x change in the quantity of good x. By definition, then the marginal utility of x is delta u upon delta x, right. Now, as the delta tends to 0, I can approximately write this as del u del x, right, or du dx keeping y constant, right. So, keep in mind that the marginal utility of good x is delta u delta x, which can also be written as del u del x, where I am using the partial derivative, which is essentially the same as saying that it is du dx, where y is treated as a constant or a parameter. Now, so for marginal revenue, we said it is the change in revenue resulting from a unit change in the quantity produced, right. It was in rupees per unit. Now, marginal utility is the change in utility resulting from a unit change in the quantity of x. So, in what units do I measure marginal utility? Well, utility is going to be measured in these imaginary units called utils, right, or you could simply call it as happiness points or satisfaction points. So, the units of marginal utility is utils per unit of x. So, I am measuring this in utils per unit of x. Okay. Similarly, let us quickly define the marginal utility of y. So, let me rewrite this. So, marginal utility of good y, and I will denote it as mu y, because now I am changing the quantity of good y and I am going to keep the quantity of good x fixed. So, the marginal utility of good y, which is mu y, is the change in utility resulting from what? Resulting from a unit change, now I am changing the quantity of good y. So, from a unit change in the quantity of good y, and while I am doing that, I want to keep the quantity of good x constant, right. So, I am changing the quantity of good y, and when I am doing that, I keep the quantity of good x the same. So, as before, a delta y change in the quantity of good y will lead to a delta u change in utility, let us say. So, a unit change in y will lead to a delta u upon delta y change in the quantity of good y, and by definition my mu y is essentially delta u upon delta y, and for very small changes in delta, this is the same as del u del y. So, mu y is delta u delta y, which is approximately del u del y, and as before, the units in which mu y is measured is utils or satisfaction points, if you prefer, per unit of good y, right. So, there are two very important definitions which are listed here. I will give you examples and we will compute mux and muy, but we will do that a little later. But for the moment, keep in mind that to derive the slope of an indifference curve at a point, I need to define these two terms mux and muy. These are two very important marginal terms. Marginal utility of good x talks about a change in utility resulting from a unit change in x, keeping y constant, and marginal utility of y talks about the change in utility resulting from a unit change in y, keeping the quantity of good x constant. Okay. Now, so let's first look at the slope and then we will take examples. Okay. So, by themselves mux and muy are not very interesting, they are very important concepts, but by themselves it is not conveying something, but the ratio is going to be very important. Okay. So, slope of an IC. Slope of an IC. Okay. Now, when you're reading this and when you're revising this section, I would suggest you take up a pen and paper and then rewrite this and try and do it yourself by looking at the lecture notes. Okay. So, let us say I have the following graph: quantity of good x, quantity of good y, and let us say I have an indifference curve like this, some indifference curve level IC1. And suppose the consumer is at some point, let me call this point to be point A, right. So, suppose the consumer is at A, he is on the indifference curve IC1, right, and at the point A, notice he is consuming some amount of good x and some amount of good y, whatever those numbers are. Let me call this as XA and YA, right. So, he is currently consuming XA quantity of good x, YA quantity of good y. Now, suppose the consumer is at A and wants delta x quantity of good x more, right. So, suppose the consumer says I want to consume delta x quantity of good x more. Now, keeping the quantity of good y the same, if you are going to give the consumer delta x quantity of good x more, right, you are going to take him to a new point A prime, right. Now, I can immediately see that because of more is better, bundle A has more amount of good x, compared to bundle A and the same amount of good y. So, clearly he must prefer bundle A prime over A, right. Pictorially, bundle A prime is going to be on a higher indifference curve level, right. So, that is going to take him to a higher level of utility, right. Now, suppose the consumer is at A and wants delta x quantity of good x more, which means his utility has changed. In fact, here I can see that he has clearly become better off. I want to quantify the change in utility, right. So, what is the change in utility? So, the change in utility, and notice when I did this change, I kept the quantity of good y the same. So, we kept y at YA and we have given the consumer delta x quantity of good x more. He wants to consume delta x quantity of good x more. So, change in utility resulting from a delta x change in the quantity of good x, right. So, a change in utility resulting from a delta x change in the quantity of good x. Well, how do I quantify that? Notice I already know the definition of marginal utility of x. I know that MUX is delta U divided by delta x. A delta x change in utility in quantity of good x, led to a delta U change in the quantity in the utility. Once more, a delta x change in the quantity of good x has led to a delta U change in the utility. So, I can rewrite this as, so since I know that MUX is delta U upon delta x, I can write, and these are discrete changes, I can write delta U as MUX times delta x. I can essentially take this here and multiply. So, my change in utility resulting from a delta x change in the quantity of good x is MUX times delta x, and notice while I am doing this, y is constant. Okay. But my objective is not to take the consumer to a higher level of utility. I want to compute the slope at the point A, right. I want to draw the tangent and get the slope. So, to be on the same indifference curve, what do I need to do? I need to take away, so from A prime, I need to take away this much quantity of good y, right. So, I need to take away delta y quantity of good y, and you gave the consumer delta x quantity of good x here, right. So I want to take away delta y quantity on good y to be on the same indifference curve, need to take away delta y quantity of good y, right. Now, because I am taking away, and when I am taking away delta y quantity of good y, notice the quantity of good x remains the same. I have not altered the quantity of good x at all, right. So, from A prime to B, the consumer's utility is going to decrease, and I want to now quantify, and the reason the utility has decreased is because I have taken away some quantity of good y. Specifically, I have taken away delta y quantity of good y, keeping the quantity of good x the same. So, change in utility, which means the change in utility resulting from a delta y change in the quantity of good y. Well, how can I quantify that? Again, I know the definition of marginal utility of y. MUy, a delta y change in quantity of good y leads to a delta u change in the quantity in the utility. So, MUy is delta u upon delta y. So, MUy is delta u upon delta y. So, since these are discrete changes, I can write the delta u as MUy times delta y, and when I did that, x is constant, correct. So, what did we do? We gave the consumer delta x quantity of good x, took the consumer to A prime, the consumer is happy, his utility has increased. Then I take away delta y quantity of good y from the consumer is brought back to the same indifference curve at the point B. In this case, the consumer moves from A prime to B, so he is going to be less happy. So, what do I know? At the end of this exercise, the consumer is back onto the same indifference curve. So, both A and B are on the same indifference curve IC1. So, since the consumer is on the same indifference curve, right, which is initially he was at A, now he is at B. What do I know? These two things must effectively cancel out, right. One, the increase or making him happier, and the decrease which is making him sad must cancel them out. But I can, or alternatively I can write it as the sum of the changes in utility, right. This was the change due to giving him delta x more, keeping y constant. The second component was a change in utility resulting from a change in y, keeping x constant. So, the sum of these changes must add up to 0, right. Otherwise, if they did not add up to 0, then either there would have been a net positive gain or a net negative gain. So, either his utility level would have increased net, in which case he would have moved to a higher indifference curve, or his utility level would have decreased in the net, in which case he would have moved to a lower indifference curve. But that is not the case. We can see that bundle B is at the same indifference curve as bundle A. They are both on IC1. So, now let us do a little bit of algebraic manipulation of this expression. So, the sum of the utility changes is 0, which then implies that I can write MUy times delta y equals minus MUx times delta x. Now, why are we interested in writing this? Notice slope is of the form delta y upon delta x, right, change in y upon change in x, or the rise over the run, right. So, the change in y over change in x is what we want to call as the slope. So, none of these terms are 0, right. So, we have taken positive changes in x, changes in y. So, let me bring the delta x here and take the MUy onto the other side. So, I can write this as delta y upon delta x equals minus MUx upon MUy, right. So, I have found an expression of the slope, and notice the slope is negative of the ratio of marginal utility of x to the marginal utility of y, which is what I said a few minutes earlier. By themselves, MUx and MUy are not very interesting, but it is the ratio which is going to convey something very, very useful, and it is the slope of the indifference curve. Now, let us do one more step to sharpen our argument. So, for small delta, right? As my delta tends to 0, we can use the limiting argument. We can essentially say that limit delta y upon delta x as my delta tends to 0 can be represented by dy dx. So, essentially my slope now is dy dx. So, I started with a discrete change, and as I am letting the delta x tend to 0, I am essentially pushing the point B closer and closer to point A. So, eventually in the limit I will get the tangent, to the curve at the point A, right. So, that is going to give me the slope, right. So, the tangent to the curve at point A, as I keep pushing the B towards A by letting the delta go to 0, I am going to get exactly that. So, my dy dx essentially is minus mu x by mu y. So, this is an important derivation, and I would urge you to repeat this exercise by yourself so that you understand this. Now, a few more things about the slope. So, there are three things here that I would want you to pay attention to. One is the sign of dy dx. The sign, as you can clearly see, is negative, right. There is a minus sign, which is consistent with the fact that indifference curves are downward sloping, right. Indifference curves are downward sloping. So, I am going to get the slope as minus whatever number you get, that is going to be a negative term. So, that is going to be minus. The magnitude of the slope, magnitude of dy dx, is going to be given by this expression mu x by mu y. We will take examples. Once I know the utility function, I can compute the mu x, I can compute the mu y. These are going to be expressions of small x and small y, and we are interested in slopes at particular points. So, I will plug in those coordinates. So, eventually this is going to be some number. So, this is going to be some number, right, which is going to tell you to get one more unit of x, how many units of y must be given by the consumer. We will write that formally. And the third and the not so very sort of the part which is hidden is the units in which I am measuring slope. Well, notice it is minus mu x by mu y. What is mu x? Mu x, recall, is utils per unit of x, and mu y is utils per unit of y. So, mu x upon mu y is essentially utils per unit of x divided by utils per units of y. We have the utils cancelling each other. So, if I flip this, I am essentially going to get units of y upon units of x, right. So, there are three things that are very, very important whenever you talk about slope. One is the sign, which is negative always, the magnitude, which is mu x by mu y, and the units, which are units of y upon units of x. So, let us take an example just to make sure that we understand this. So, suppose I have a utility function which is x times y. So, this is my utility function. So, I know that my utility function is of this form, right. This is my utility function and leading to some indifference curve IC1, and suppose I am told to compute the slope at some point 2, 10. So, find the slope at A equals 2, 10. So, this is the particular coordinate where we want to compute the slope. Now, I know that computing the slope essentially means we want to compute dy dx, which is minus mu x upon mu y. This is what we are interested in computing. So, all I need to do is I need to compute what mu x is and I need to compute what mu y is. So, let us compute mu x. Mu x, recall, is delta u divided by delta x, which for small changes in x can be approximated to del u del x. So, I can take the derivative of the utility function with respect to x, where y is kept as a constant. So, this is del x of x times y, and here y is a constant, so I can essentially pull the y out, times the derivative of x with respect to x, which is going to give me 1. Similarly, MUy is del u del y, which is del y of again x times y, right. So, it is delta u upon delta y, which for small changes can be approximated as del u del y, keeping x constant. So, I take the x out, find the derivative of y with respect to y, which is going to give me 1, right. So, as I said, MUx and MUy for this particular functional form x times y is going to give you dy dx is minus MUx by MUy, which is y upon x, and at the point A, this is essentially minus 10 by 2, because that is my coordinate. The y coordinate is 10, the x coordinate is 2. So, I am going to get minus 5 units of y upon units of x, right. So, the slope of the indifference curve at the point A is minus 5 units of y upon units of x. Now, if I take another example, u of xy is equal to, let us say, 2x plus y, which is an indifference curve that we have seen a little earlier. So, if you recall, we have drawn the indifference curve u of xy is equal to 2x plus y. So, suppose I want to find out the slope of this indifference curve at some point, let us say, let's compute the slope, right. So, what do I get? I know the indifference curve for this utility function is going to be of the following form, right. So, this is going to be the indifference curve. The indifference curve is going to be of this particular form. They are straight lines. Now, because the indifference curve is a straight line has a constant slope, the slope of this indifference curve is going to be a constant number. Let us check. So, dy dx again is minus MUx by MUy. Now, notice MUx is the derivative of is del u del x. So, that is the derivative of 2x plus y with respect to x, keeping y constant. So, that is the derivative of 2x with respect to x. So, the 2 will come out and the derivative of x with respect to x is 1, and then the derivative of y with respect to x, where y is a constant, is essentially going to be 0. So, I am going to get 2. MUy is the derivative of the utility function with respect to y, where I am treating x as constant. So, because x is constant, that is not going to contribute. So, when I take the derivative, I am going to get 0, and the derivative of y with respect to y is simply going to give me 1. So, that is going to give me a value 1. So, therefore, dy dx is minus MUx, which is 2, divided by MUy, which is 1. So, that is minus 2 units of y over units of x, right. So, once you give me a utility function, I can use the definition dy dx equals minus MUx by MUy and simply compute the derivative at various points along that indifference curve. And because the indifference curve is a downward sloping line, the slope everywhere is constant. So, irrespective of whether I am trying to compute the slope here or at any other point here, in this particular example, the slope is going to be minus 2. But that is not true for the previous example of u xy is equal to x times y. Here, because it is a curve, the indifference curve is not a straight line, it is a curve. The value of the slope at various points is going to be different. Pictorially also you can see, if I draw a tangent here, this is what it is going to look like. If I wanted to compute the slope at some other point b, the tangent is going to look somewhat like this, right. So, go back and try these examples again so that you understand them better. What we will do next is, we have now defined slope. Using the slope, we will define a very critical concept called the marginal rate of substitution, which is going to be the central part of our discussions. We will do that in our next class. Thank you.